Balancing Equations, Part 2, Combustion Reactions. Combustion reactions involve a carbon, hydrogen, and sometimes oxygen compound reacted with oxygen. With sufficient oxygen, the products of a combustion reaction are always carbon dioxide, CO2, and water, H2O. When balancing combustion reactions, balance the atoms in this order: carbon first, hydrogen next to last, and oxygen last. If we look at our flow chart, in this presentation we're going to focus on combustion reactions. In a combustion reaction, you're going to have a carbon-hydrogen compound, sometimes oxygen, plus oxygen and two or more products. We're going to assume complete combustion, which means we will get CO2 and water. That means there's enough oxygen for the reaction to go to completion. Example 1. Use the balancing equations flowchart to determine the type of chemical reaction and balance the following equation. Notice we have a carbon-hydrogen compound plus oxygen. Our products, because it is a combustion reaction, will always be CO2 and water. The first thing we do is we write down what we know. We have one carbon, 4 hydrogens, and 2 oxygens on the left. We have one carbon, 2 hydrogens, and 2 plus 1 is 3 oxygens. The first thing we do is we balance our carbons. Our carbons are balanced. The next thing is our hydrogens. So to balance the hydrogen, we put a 2 here. 2 times 2 is 4 hydrogens. It also changes the oxygens. You have 2 times 1 is 2 and 2 is 4. So now we need to balance the oxygens. We put a 2 here. 2 times 2 is 4. And now we have 1 carbon on both sides, 4 hydrogens on both sides, and 4 oxygens on both sides. The equation is balanced. Example 2. Use the balancing equations flowchart to determine the type of chemical reaction and balance the following equation. We have a carbon-hydrogen compound plus oxygen. We will produce CO2 and water. We're going to assume complete combustion. Hint: when the oxygen atoms, the O2 atoms on the left, the reactant side, will not balance with whole numbers, multiply the coefficients at that time by 2 and start over. We write down what we know to begin with. We have 2 carbon atoms, 6 hydrogen atoms, and 2 oxygen atoms on the left. We have 1 carbon atom, 2 plus 1 is 3 oxygen atoms, and 2 hydrogen atoms on the right. We start by balancing the carbon atoms. We multiply CO2 by 2 to balance the carbons. The hydrogen, we multiply water by 3. 3 times 2 is 6. Now let's see what happens to our oxygen at that point on the right side of the equation. 2 times 2 is 4. 3 times 1 is 3. 4 plus 3 is 7. There is no whole number you can multiply 2 by to get 7 on the left. So now you will multiply each of the coefficients at this point by 2 and start over. So we will put a 2 in front of the C2H6. 2 times 2 is 4 in front of the CO2. 3 times 2 is 6 in front of the water, and then we'll balance the oxygen. 2 times 2 is 4 carbons. We're going to add a 4. 4 times 1 is 4 carbons. 2 times 6 is 12 hydrogens. 6 times 2 is 12 hydrogens. Now we've got 4 times 2 is 8 oxygen atoms, plus 6 times 1 is 6 oxygen atoms on the right side of the equation. 8 plus 6 is 14. 14 divided by 2 is 7. We will write a 7 as our coefficient. The correct balanced equation is 2C2H6 plus 7O2 yields 4CO2 plus 6H2O.